All right, today in lesson 4-6, we're going to talk about situations that always happen or situations that never happen. And in math, what happens when you have situations that always happen is something is true. Okay, that inequality or that equals to always happens. Okay, it's the same thing. They lie on top of each other, or it could always happen. Okay, um, when it never happens is also another situation where it's going to show you this can't be. 3 cannot be less than 5. Okay, and we got to pay attention to these special situations. It says some linear sentences have no solution and others are true for all real numbers. And we're going to look at that. So, comparing situations, which job would you take? Job 1 has a starting salary of $30,000 and raises $5,000 each year. Job 2 has a starting salary of $28,000 and raises $5,000 each year. Well, if you look at this, my starting is $30,000 and it raises y equals $5,000 each year. Okay? Job 2 says it starts at $28,000 and increases at $5,000 each year. So what I want you to pay attention to right here is this $5,000 and this $5,000, they both go up at the same rate. Everybody's getting a $5,000 salary increase every single year. So which job would you take? Well, you would take this one. Why would you take this one? You would take job 1. Because job 1 is always going to be $2,000 more than job 2. Because this one starts at $30,000 and this one only starts at $28,000. So every year, job 2 is going to be $2,000 behind. Now let's take a look at that, what it looks like when you do your math. Okay? It says, when is the pay in job 1 better than the pay in job 2? You must solve. Okay? 30,000 plus 5,000 N has to be greater than 28,000 plus 5,000 N. So same process. We have an inequality. We got to get our N's together. We got to get our regular numbers together. So the first thing I'm going to do is I'm going to subtract 28,000. 28,000's gone, leaves me with 2,000 plus 5,000 N has to be greater than 5,000 N. Now I got to get my N's together. So the inverse of adding 5,000 N is subtracting 5,000 N. And what some people have a problem with when doing these problems is they don't like to say is greater than 0. Okay? When you get rid of those, you're left with 2,000 on the right-hand side is greater than. They're always looking for a number. They don't like their variables to cancel themselves out, but it's fine. It's totally fine. 5,000 minus 5,000 is 0. So what this is saying is, when is the pay in job 1 better than in job 2? All the time. 2,000 is always greater than 0. So what this is saying is, job 1 is always $2,000 more than job 2. Okay? See how you do your math? Don't worry about your variable being gone. It's telling you a valid piece of information. Okay? So mark this down here. Sentences that are always true. When solving a sentence, if you get a sentence that is always true, then the original sentence is always true. So if you go back here, is 2,000 greater than 0? Yes, that is always true. Therefore, job 1 is always better than job 2. Going back here, when does job 1 pay less than job 2? We kind of know the answer to that, but looking at the table or graph on page 216, this never happens to be true. To answer this algebraically, you could solve. So if you looked at our graph, you're going to see that job 1 is never less than job 2, okay? But we're going to do this algebraically just to show you. So same process, I subtract 28,000. Because that's what the less than would mean. When is job 1 less than job 2? So I get 2,000 plus 5,000 n is less than 5,000 n. I subtract 5,000 n from both sides. Leaves me with 2,000 is less than 0. Is 2,000 ever less than 0? Not true. So, job 1 is never less than job 2. Okay? Moving along, sentences that are never true. When solving a sentence, if you get a sentence that is never true, then the original sentence is never true. So kind of the same way, just work backwards. I got a sentence here that wasn't true, so I knew that job 1 will never pay less than job 2. Let's look at some true and false sentences down here. A true statement looks like this. 0 equals 0. That's true. Therefore, any solution will work. 92 is less than or equal to 92. Is 92 less than or equal to 92? Yes, that works too. Here are some false statements. 0 equals 3. Does 0 equal 3? No. Is negative 9 greater than 14? No. Since those are false statements, that means there is no real number to satisfy those equations. So let's take a look at more of these. Okay, here's an algebra problem. Solve 18m minus 20 plus 3m equals 3 times the quantity 7m plus 2. So the first thing I'm going to do is I'm going to get rid of those parentheses. Three times 7m is 21m. 3 times 2 is 6. Okay? Now here I'm going to dress this up. I got some m's and m's, so I need to put those together. 18m plus 3m is 21m. Minus 20 equals 21m plus 6. Okay? So, I get my numbers together. The first thing I do is the inverse of subtracting 20 is adding 20. Gives me 21m equals 21m plus 26. Okay? I need to subtract 21m. Zero equals 26. Does 0 equal 26? No. So there is no solution. This can never happen. This will never equal this. Okay? Example 2 says solve 42k is less than 80k plus 6 minus 38k. Okay? So what they did for us is they put our k's together here. So 42k is less than 80k minus 38k. I'm just combining these. Is 42k plus 6. So they want to know when this is less than this. Okay? So on my graph, and this is what it looks like when you graph stuff like this, but here's my 42k plus 6. It's going right here. And here's my y equals 42k. Okay, notice they're parallel. And if this one is on top of this one, that means this one is always going to be greater than the red one. The blue one is always going to be greater than the red one. So here's blue, here's red. Does this say blue is greater than red? Well, my graph shows that. So yes, this works out. Okay? The other way you could do this is finish this algebraically. So what I would do is subtract 42k from both sides. Gives me 6 is greater than 0. Is that true? Yes. Therefore, this is always true. All reals would be my solution. That's all I have for you today. I hope this works out for you. We'll see you tomorrow.